Welcome to a lesson with Dr. Powell. Let's take a look at inverse functions. So let's suppose, for instance, that we have f of x is equal to 2 minus square root of x plus 3. Now, if we'd like to find a function which undoes or reverses what this function does, we call that the inverse function. So what does that mean? That means if you plug something into this function, then the inverse comes along and says, I don't like what you did. And so it takes the output of this function, which is notated by f of x, and it outputs where we started. So it says, don't do what you just did. I'm going to take you back to where you were before at x. So for instance, if we were to plug in 1 into this function, f of 1, the output would be 0, because we have the square root of 4, and then with 2 minus that, so it would be 0. So f of 1 would be 0. Okay, so this is 0. But f inverse says, nah, I don't like what you did. I'm going to put you back over to 1. So that's what the inverse function does. It undoes. Now, another way of thinking about that is you're switching your inputs and outputs. So you take an output and you put it back to its input. So it's like you're reversing or kind of switching things around. So we'll think about this geometrically as well as algebraically. So for now, let's go ahead and look at it algebraically. What you could think of this as, if you have a y representing output and an x representing input, then given that idea, to get the inverse, you simply switch your x's and y's if you let y always be equated with output and x is with input. And so to get the inverse function, we just swapped that y and x. So x is equal to 2 minus the square root of y plus 3. And then we solve for y. So we could bring the 2 over, so x minus 2. And then multiply both sides by a negative, and then square. I guess we could have just squared both sides, but whatever. I mean, we got the same thing eventually in the end, is equal to y plus 3, and then we can subtract the 3 over. So get 2 minus x, quantity squared minus 3 is equal to y. Okay, so we can think this is now output and that's input. And so we can represent formulaically what the inverse function is. But this isn't quite all the way true, at least not quite yet. Let's think about this for a minute. First of all, why don't we graph? Why don't we do what we just were doing graphically? Because in the computation, there's some things we have to be watch out for, and the graphs will help. So first, let's look at this graph. So this is like the graph of square root of x. It's been shifted to the left 3 in here. And then outside the square root, looks like we've first reflected, and then we shifted up 2. So should be at -3, and then we're kind of up 2, and we reflected down. Okay, so it's coming down like that somehow, however it goes. Okay, so that's the graph down here. Now let's look at this graph right here. All right. In fact, you could rewrite this. You see how you're squaring? So you could freely put a negative inside of the square and distribute it across. It would be just fine. Think of it as x minus 2 quantity squared minus 3. This looks like a parabola that's been shifted to the right 2 and down 3. So here to the right 2 and down 3. Notice how it's in reverse of those ideas with x and y. Okay, and it's been shifted, and it's still pointing upward. So up and up. Okay. Now, graphically, the same thing should hold if we switch x's and y's. If we switch x's and y's, it's kind of like we're reflecting across the line y equals x, where y equals x, where they're the same in the reflection, you would stay on this line. Now, there are some issues with this. If we reflect this right here across this line, we should get this, and we should get this up here. So we should get this part of the parabola. But there's a problem. We also see this part hanging out over here. It's actually too much. And a way to see that is, well, first of all, range and domain will swap places. The range here is everything up until 2. That means the domain has to be everything up until 2. So we're only going to be taking this part of that parabola, meaning that we actually have a restriction here when we write down our equation for our inverse. We would take what we've got here, which is 2 minus x quantity squared minus 3, but then we'd have an extra condition. X is less than or equal to 2. So this really is the full inverse. Let's think about that in another way. This right here, let's work backwards. Let's suppose we have this function right here. It's a parabola. What happens if you swap your x's and y's? You swap how you look at it, and the graph will appear like this. Notice that when you swap your x's and y's, you end up not having a function, meaning that this has no inverse function. So therefore, to have an inverse function, you have to eliminate any part of it so that when it's turned on its side, it still passes the vertical line test. So that's why we restrict domain when we're thinking about this. If we wanted to find the inverse of this guy, we'd have to be careful. Now, this guy right here originally actually does have an inverse, and we can be sure of it because when we reflect it, it passes the vertical line test. Thanks for watching.